Hello everyone, I am Virendra Kujwa. I am going to discuss an important topic in machine learning, that is support vector machine. In short, it is known as SVM. Starting from the first slide, that is point to be discussed in overall this lecture. First point, we have why support vector machine. Second point, what is support vector machine, and third one is understanding support vector machine concept. So, what is machine learning? Machine learning is basically an important area or a subfield of artificial intelligence in which we need to understand how a machine can learn. So, there are so many definitions given by there are so many scientists and mathematicians. So, this part we have already seen in previous classes. So, but in machine learning, we can say this machine learning is divided into three important categories. One is supervised learning, next one unsupervised learning, next one reinforcement learning. But now question we have, that is why supervised learning and what is supervised learning? Machine learning model learns from the past input data and makes future prediction as output. So this is the pure definition of the supervised learning. In this example, we can say if we have model which is need to identify it is strawberry or any other fruit. So the model will be trained and just find the answer and just predict the accurate answer. This is the strawberry. So now continue from the previous slide, supervised learning, unsupervised learning, and reinforcement learning. As we know, there are three categories of the machine learning. But machine learning it has all the various kind of the learning approach or algorithm. In supervised learning, we can say it is divided into the two important sub algorithm or main algorithms. First one is classification algorithm and next one is regression. So regression we have seen the logistic regression, linear regression, polynomial regression. In the classifications we have the various kind of the algorithms. Logical regression is a good one example for using the classification. So now support vector machine is an approach or a technique which is used by the combination of both of these important algorithms. First one is classification algorithm and next one is the regression concept or regression algorithm. Now, why support vector machine? Now, last week my son and I visited fruit shop. So my son will ask a question, Dad, is that an apple or a strawberry? So I was a little bit confused. So after a couple of seconds, he could figure out that it was a strawberry. As you can see in this slide, overall presentation will be nice and neat by through the diagrams or pictorial representation. The overall example we will see through the pictorial representation and the concept will be very interesting part. So now the final outcome is it is a strawberry. So my son will be happy. Finally, he got the answer. So now question we have that why not build a model which can predict an unknown data. So past level data which is could be the apple or strawberry. So after the training the model and predictions, the model after getting the new data, now output will be finalized that is could be the apple or strawberry. So now the answer is strawberry because I just modeled my this model or this diagram through the previous example as we can see the finding the strawberry or an apple. So finally I just find the answer which was the strawberry. So this is a support vector machine. So this concept is known as a support vector machine. So overall approach, overall process to find the correct answer, predict the answer is known as a support vector machine. So continue from the my next slide. That SVM is what? SVM is a supervised learning method that looks at the data and sort it into one of the two categories. What are the two categories? The first one is the classification, next one is regression. So now question we have in our mind that is how does the prediction work? It is a good question in our mind and it should be the good question. So now you can see the overall approach here that the prediction is main important part because prediction is the important factor, important parameter which is used to predict the correct answer or find the good accuracy. So depend on the what kind of accuracy we have, so answer will match on the right path. So prediction is more important part. So in the this slide we have just seen how does the production work. So we will see this part in the coming slides. Now see this slide. SVM, the overall approach is just given to the different approach. So first one is a level sample data. Next one is decision boundary. Next one is plotting the data and predicting the unknown and the output. So here what we have the previous diagram. So we have seen this diagram. Now in the support vector machine, what I have just given, we have just given the label sample data and we need to define the decision boundary. Decision boundary is the boundary in which we need to divide the data. Either it could be the apple, it could be the strawberry. And after giving the some input data for the new data, the new data for of the fruit, it could be strawberry or it could be apple. So suppose I am giving the strawberry or suppose I am giving the apple. So data will be matched or data will be predicted as per the required or desired parameter. So finally prediction will be done over this step, and then finally we will get the output. So this is the important approach we need to go. The overall approach will be done by the important concept which is known as the SBM. So here we need to understand what is a support vector machine. In the previous slide, we have seen the decision boundary is more important factor. Why we just categorize or classify the strawberry and apple part. So because without the classification, we can't understand the overall concept. So the SVM is a combination of the both important approach. One is classification and next one is regression. So here we are starting the concept of what is support vector machine. So let's take an example. By this example, we are given a set of the people with different parameters. One is the height, and next one is the weight. So see, some sample data is taken from the two important part. One is for the female and other one for the male. So in female, what we have taken the height and weight, while in a male category, we have also put the same thing. So in a female, we have seen the height, we have seen the weight, or we have taken some data as you can see over here. And in case of the male, what we have taken the height and weight of the different person or different people. So this is the sample data set of the female and male. So we have just taken the data set or data. After getting the data, what we are doing, we just let's add a new data point and figure out if it is a male or female. So we have just plotting the data or plotting the information. So here this is for what? This is for the female and this is for the male. So this is a classification which is represented by the plotting, but the question is let's add a new data point and figure out it is male or female. So what is the question is here the question is to just predict it is male or it is a female. You can see we are just adding a new data point which is used to just predict it could be male or it could be a female. So the question we have again, that is let's add a new data point and figure out it is male or female. So this is our new main objective by which we need to figure out the such information next. So for doing such a task or activity, we need to split our data first. So you can see there are the two category of classification of data. One is a male and female. So the data should be classified in proper manner. So now we can split our data by choosing any of these lines. So this is a line one. This is a line two. I'm just what I'm doing over here. I'm just dividing the or classify the data. Next one is, but we need to predict the gender of a new data point. We should split the data in the best possible line. So here to two line one and line two. Then I would say this line best split the data. So line one is as I'm taking over here. This is the line one. I'm just skipping line two. So why do you say this is the best split line or not? So next. Here in the slide, you can see the maximum spaces over mentioned here. So the what we are doing, we are just selecting a line one rather than line two. In the line one, we are just seeing over here that the data is divided into important category male and female. But here we have the closest point or closest data points here. This is the closest point from the male data, and this is the closest point from the female data. The blue line, which is the line one, this is also known as the hyperline. So in this category, or in this case, what we're doing, we're just dividing our data into different part, and here this is known as the new data pointer which is to be predicted. So what we have done, what we are doing also doing here, this the maximum space is mentioned over here. Why the maximum is, what is maximum space? The maximum space is the closest line from the new data point to the female existing data point, and this line belong to the closest point which is just marking from which is marking from the male data point. So there's a gap between the male marking line and the female marking line. So this line should, the line one should be lie between these two markable line. So the maximum space will be counted from the female and male markable line. So in this line has to maximum space that separate the two classes. What are the two classes? Class is male class and female class. While the other line 2 does not have the maximum space that separate the two lines. So as you can see over here, it is very simply and easy to understand. Line 1 has the maximum space between the two dotted lines, while the line 2 does not have the maximum space. So we can't take this line 2, we have to accept, or we have to take line 1. So next is why this line best split the data. So we have just taken the line 1 except to line 2. So here finalize the line 1. So this is the question, why this line has the best split the data. Well, yes, this is the best split data because the line 2 does not have the maximum space, line 1 has the maximum space. So we are just taking the line 1. So now let me add some more technical term to this code. So this is you can see the maximum space is also known as the distance margin, and this is the blue line is not line one, which is taken by us or selecting by us. So this is known as a line, and now this is the male data and this is the female data which are closest to the line one. So these are known as the two important points. The point which is a male point and is a female point. In the technical terms, we can say that the distance between the support vector and the hyperplane should be as far as possible. Here it is very clear to understand what is a hyperplane. Hyperplane, so it basically is a gap. It is a line. So line one is also not a hyperplane, while the support vector is what? Support vector are the nearest data point from the male data set and the female data set. Here you can see easily identified and see that there is a one female and one is a male closest or nearest or extremely data point which are known as the support vector. Here the support vector, here the support vector. These are the support vectors. By the learning from these support vector, we will try to learn to make our machine as a learning oriented. So here the machine learning just does play important role to deal with such kind of the SVM means support vector machine. So support vector machine means there are some vectors which are used to making the support for making a machine to be learning oriented. So this is just idea about the support vector machine as well as the machine learning needed as in form of the support vector as support vector machine. Where support vectors are the extremely point in the dataset, as I already said in the previous slide. And hyperplane has the maximum distance to the support vector of any class, as this point is also we have seen in the previous class, previous slide. Here d plus is the shortest distance to the closest positive points. So now this is the d plus, and again we have the d. So and d minus is the shortest distance to the closest negative points, as you can see in the slide. Next one is sum of the t plus and t minus is the called the distance margin. This is known as the distance margin, and this is also known as the maximum space. From the distance margin, we can get the optimal hyperplane. So distance margin, we can find the optimal hyperplane. Based on the hyperplane, we can say the new data point belong to the male gender. So this is the point where we are just talking about this important part. Based on the hyperplane, we can say a new data point belong to the male gender. So that was a so clear concept. Now, but what happens if the hyperplane is not optimal? So if we select a hyperplane having a low margin, then there is a high chance of misclassification. So what to discuss so far, we have this is known as the LSVM. LSVM means low support vector machine. Next one is understanding support vector machine. To understand assume in more detail, so if we are just taking the data set in this way rather than in this way, means this is the data which is easy to classify, but here we can't classify the data in easy manner, or we can't define the hyperplane in this data set. Here we can't use a hyperplane, so it is necessary to move away from one dimension view of the data to a two dimension view. For the transformation, we use a kernel function. So here you can see in this diagram what is input, and the kernel function is changing our data one dimension into the two dimension. So which will take the two one dimension input and transfer it to the two dimension output. So input we can inform of the one dimension, and kernel is a function by which is used to convert one dimension data into the two dimension. So this process is known as transformation, and here you can see in this diagram our equation is defined as y is equal to x square. So here the data is converted into the one dimension to two dimension, and this is the line. This is the red line. This red line is known as the hyperplane. So our data is easily classified or divided into two different parts. Now, how to perform SVM for this type of the data set? So this is the sample data set we have taken, because here there is a data is plotting in a different nature. So here the sample data is given over here. So we need to segregate the data into classes. So but which is not an optimal solution, because hyperplane it does not clearly divide or define the data set into in two different manner. So here we need to apply the kernel function. So kernel function will change our information to the two dimension to the three dimension. So ultimate objective of kernel function is to change the data one dimension to the another dimension. Here we can see the 2D data is transformed into the 3D data. So now what is the advantages of support vector machine? There are so many advantages of support vector machine. The support vector machine can be used to define high dimension input space, used in the sparse document vectors and regularization parameters. So there are basic three application advantages where we can use the support vector machine. So this is overall from my side about the SVM, which is a support vector machine. This today we have seen what is mean by support vector machine, why support vector machine is required in machine learning, and what is understanding the SVM in short manner through a best example and also simple example. Today we have seen what is mean by SVM, what is mean by the hyperplane, what is the role of the distance margin, what is the need of the support vectors, and what is the purpose of using or adding a new data point into the existing data set, and just to predict the best or relevant output. And there are certain questions we have in our mind: what is accuracy and what are the various parameters by which we can calculate or estimate higher or more higher accurate data point or data result in terms of the different manner. So this is a little bit idea about the SVM from my side. Thank you all of you for listening me. Thank you once again.